All right, so in addition to simple random sampling, which we know is statistically sound, what are some other ways that we can do sampling so that it is going to be fair, meaning representative of the population in question? Okay, so the big idea here is that if you're going to be statistically sound, you must have randomization involved. Okay, so must involve randomization. Now again, that does not mean a simple random sample necessarily, okay? And that does not mean go ask random people on the street, go ask random people that you pass. That's convenience, okay? But randomization meaning everybody had an equal chance of being selected, all right? So let's look at some specific types, and there are others, but these are kind of the three actually that are most commonly found. All right, so a stratified sample. You separate the population into non-overlapping groups. Okay, so for example, here's the population. Okay, we separate them into non-overlapping groups, so everybody belongs in one of those four categories, and you obtain a simple random sample from each group. So maybe you pick those people and you pick these people here, and you grab these people here, and you grab these people from over here. Okay. Another way to look at this would be that you choose some from all of the groups. Okay, you choose some or choose a few from all of the groups. All right, now a couple other notes. You do not need to pick equal numbers from the strata. Okay, so do not need to choose equal numbers from each strata or group. Strata or group. Okay, why would that be? Well, for example, let's say you're talking about freshmen, sophomores, juniors, and seniors, and let's say you have a really small freshman class compared to, say, the senior class or the junior class. Well, it wouldn't necessarily make sense to have equal numbers of freshmen, sophomores, juniors, and seniors represented or chosen, if you have far fewer freshmen. So maybe you select fewer freshmen to better represent the population, okay? And I'm going to actually use that as an actual example here for what happens. So let's say at a high school, you do randomly select, so there's that, you randomly select a certain number of freshmen, sophomores, juniors, and seniors. Okay, so within a group, think of it as you put all the freshman name in a hat and you draw out however many you need. Okay, you put all the sophomore names in a hat, you draw out however many you need, but you do not have to draw an equal number of freshmen, sophomores, juniors, and seniors. Okay, so that's stratified sampling. All right, next one we're going to look at is systematic sampling. And this one is a little bit different than the last one. So it is obtained by selecting a starting point at random from the population and then selecting every kth meaning 10th, 50th, 22nd, whatever, individual. Okay, this one is done a lot in like manufacturing scenarios. Okay, so I'm going to give you a manufacturing example here. Let's say we're in an Oreo cookie making factory. Okay, Oreos. Let's say you randomly select a package as a starting point. Okay, and that could be something like, hey, we're gonna use a computer or whatever to pick a day and a time right down to the second at random. And that package that comes off fully packaged at that day, time, and second, that's the starting point. Okay, so that starting point has to be chosen randomly. Okay, and then from there, you're going to sample, say, every 100th package of Oreos. Okay, now what would you be sampling for? In this case, probably weight would be a great one. Whenever a package advertises it has so much product in it, you can get in a lot of trouble if you don't have that much product in it, so they could weigh it. Perhaps they've started using a new packaging mechanism and they want to see that the new material or that the way that they're sealing it is working well. Again, lots of different options there, but generally speaking, with product sampling like that, it's usually related to a weight quality control issue more so than any other. Okay, so systematic, start at a point at random, that's really important, and then pick every however often. Okay, again, up to you how often you want to do that. All right, and then cluster sampling is the next one we're going to look at. So here you break your population into groups called clusters. Okay, so I'm going to draw a picture sort of like I did for stratified sampling. So here is our population, and we break this into groups that we're going to call clusters. So there's our clusters. And then you randomly select clusters and poll everyone in those clusters. So you randomly select clusters and you poll everyone. So you would give everyone in that cluster, for example, maybe this one and maybe this one here. Okay. So so this is, let me give you kind of a choose all or survey all. Let me change that to survey. I think that'll be a little bit clearer there. So you survey all. Sorry about the dog. Hold on. Sorry, that was Teddy. All right, so you survey all from some of the clusters. And again, the clusters have to be randomly selected. So how would this work? Okay, let's take an example here at ICC. Let's say each section of all courses, okay, so every section of classes that we teach, so each section of all courses taught is a cluster. And then we randomly select, say, 25 sections and survey all students in those 25 sections. Okay, so you survey all from some. All right, so that's a little different from cluster and a little difference between cluster and stratified. All right, so example 2 has 5 different scenarios that ask you to identify what kind of sampling we've got going on. Your choices are going to be cluster, systematic, stratified, simple random sample, and also convenience sample. Please pause the video, fill out the 5 the way you think that they are, okay, and then come back and compare with me. All right, check and see how you did. So for A, you should get systematic. Giveaway there every 10th. For B, stratified. So again, divided into 3 groups, and then some people from each of the 3 groups were selected. Okay. C, a radio station asked to call in. That's good old convenience. Okay, they're not going out of their way to do anything special there. 200 people are randomly selected from Illinois. So again, not out of smaller groups or whatever. It's like everybody's name was in the hat and they could have been picked. And then A medical researcher at Johns Hopkins interviews all leukemia patients in each of 20 randomly selected counties. So if you think of the country as a whole bunch of counties, okay, whole bunches of counties, and then from there, okay, they took the leukemia patients in 20 of these specific county, or all the patients in 20 counties randomly selected. Okay, so that'll tell you how that works. All right, wrapping up this section. So this being a census year, hopefully you all know what a census is, okay? But a census is where you poll everyone in a population. All right, not hard to do if your population is, for example, the 12 men who have walked on the moon. All right, but very difficult to do when your population is, oh, say, the United States. Okay, so what are the advantages of a census? These are the most accurate results. Because everyone participates. Okay, and what are the disadvantages? Two big ones: time, and number two, money. Okay, it takes a lot of time. The census started, oh golly, back in the spring for 2020. I think I got mine back in like February. And there are still commercials and so forth on right now encouraging people to fill out their census, to go online and fill it out. So it takes a ton of time, and it does take a lot of money to reach everyone. Lots of mailings, lots of commercials. If an address doesn't respond, and then they actually send people out to that address to try to track down who's living there. Just a lot of time and expense.